everyone. I'm Beck, Editor-in-Chief of Machine Design. Welcome to this Tech Exchange edition. I'm checking in with Anders Beck, VP of Innovation and Strategy at UR, otherwise known as Universal Robotics or Universal Robots, right? During our conversation, we'll talk about 5 AI-powered solutions developed by UR and its partners. Thanks for joining me, Anders.
Thank you so much. I'm happy to be here.
Yeah, so, I know that this week you are rolling out your AI accelerated toolkit. And this is a package that you've developed or you've designed in collaboration with NVIDIA. So this application enables the development of AI-powered applications through UR's Polyscope X software platform. Correct so far?
That's exactly right. That's exactly right.
And I believe the toolkit is powered by NVIDIA's Isaac and its accelerated libraries and AI models, and it runs on the NVIDIA Jetson AGX Orin system on module. So there's a lot to unpack here. We know that robotics and physical AI deployments are on the rise, and I also know that these advancements are driven by generative AI and simulation. And in this case, in your case, with NVIDIA's Isaac robotics platform. Can we please start our conversation with an explanation of what we mean by physical AI?
Absolutely. So I think we all can recall sort of the last couple of years where AI has been dramatically on the rise across a lot of different, you could say, non-physical applications. That's everything from we remember like ChatGPT. We all use it even more and more for text generation. We see image generation using AI, generative AI, and even in gaming, a lot of the generation of beautiful scenes in games and so on. All of that is by now AI generated. So we've seen it, and that has been working tremendously, right? There's no doubt that we've seen the big changes that are doing across a lot of industries. Sort of one of the remaining frontiers of AI is yet to make it do a dramatic impact to the physical world. And this is where things gets challenging. I think all, and especially your audience here, really knows how difficult it is to design things that manipulate, that change, that impacts the physical world. So physical AI is really the ability to taking the advancements that we see in AI today, take them into the physical world, especially through robotics, but it's actually also for autonomous driving. It's also sort of a lot of other physical interactions, but it's no doubt that robotics is the place where physical AI will have its sort of access to the world to really make an impact across a lot of different applications.
I wonder if also you can expand on the idea that, everybody's talking AI and we don't really know what is behind it. So I'm hoping that you can walk me through some examples. I know that you have a rollout of about 5 different applications that you can speak to on this call alone. So I wonder if you can help. Let's walk through each one of those. I will list them and then you can delve into them. Help our audiences understand what the actual AI is behind each application. So let's talk first about the your UR partner solutions on display at that you're doing at NVIDIA GTC, which is where you are right now.
Okay.
So the first is the 3D Infotech Dynamic Metrology. What exactly is that?
So 3D Infotech is a company that does metrology, right? So it's not recognizing objects, but it's measuring. So it's measuring for quality inspection, using robots to scan parts and understand if they are up to par with whatever manufacturing specifications. And using robots for that is a way to really accelerate it and have much more flexible, cost-effective machinery than traditional larger sort of coordinate measurement machines and so on. 3D Infotech is adopting AI for both like correction, making it much faster to identify the parts, to plan the scanning around. Because the challenge is using a robot for scanning parts is actually relatively challenging if you want to move the robot around, if you have a part or if you have multiple parts, if you want to do inline quality inspection, that could be for moving line and so on. Then using AI to both recognize the part, to plan the robot's motion around the part, and then using the metrology systems to measure, scan the part. So in this case, the AI element is for the image recognition, which is a thing that AI is very, very strong at, and it's being adapted even more. But also for accelerated planning, so plan very smooth and precise robot motions around the part, which could, in many cases, have different orientations and so on. So it would need some level of adaptability across. So it's a really exciting sort of evolution of the 3D Infotech system. We're using AI to accelerate both deployment, but also making it much, much more user-friendly to people that doesn't need to be a robot expert if you want to do metrology on parts where positioning could be different and varying over time. So I think it's a very exciting application for AI.
Yeah, and just to summarize, I guess your showcase at NVIDIA's showcase at NVIDIA GTC, you are using your 3E cobot, right? And I read that you're scanning you're scanning a workpiece, comparing it with 3D CAD models or CAD models, and then it highlights dimensional inaccuracies. And then projecting this onto the workpiece surface. What happens then?
That's the main function, right? But you're completely right. For metrology, it's all about as a manufacturer. It could be in development departments. It could be for inbound quality inspection to validate if the parts you get produced matches to what you expect. And 3D Infotech has done it in such an intuitive way that you scan the part with very high accuracy, down to a few microns in accuracy, and then it can project a color coding directly onto the workpiece. So it would highlight exactly, it would recognize the part, and it would sort of back project a color scheme that would highlight, maybe even given to the manufacturer's tolerances, or just in general divergence from this 3D model. It would put a beautiful color coding on top, so you would be able to see upfront without having to use complicated computer systems. You'd actually see where this part either need to be reworked, or where you may have, could be casting challenges if the casting is not accurate, or machining tolerance problems, and so on. So it's a very intuitive way of using AI in such a quality metrology for workflow.
Yeah, very good. I'll go to the next one. This one looks at CNC machine tending, and I believe it's with T Robotics, Gen AI driven programming. What is behind this application?
So this is one of the more exciting ones. So T Robotics is a Norwegian and Silicon Valley company that wants to dramatically simplify applications where you need some level of rapid changeover. CNC machine tending is a good example. Often in CNC machining, you would run moderate-sized batches, anything from 10 parts to a couple of hundred parts. So having the ability to do changeovers, not only on the CNC machine, but also in the robot system that feeds the CNC machine is mandatory to be able to do this small lot size applications. T Robotics are using generative AI to make that really simple. So what they have built is a chat prompt. So you can prompt the robot and it generates the robot program. So you think about it as chat GPT, but similar interfaces where you could, instead of generating text, it generates robot actions. So you can explain to it how the parts look, how you want it in, how it's structured in an in-feed, and it generates the robot program behind. So I think it's one of the really good steps of where you can see generative AI simplifying deployment. Because I think many of us recognize that one of the things that generative AI is great at is to replicate things that it sort of knows in advance, right? Like if you think about ChatGPT, it's been trained on all the text in the internet and can then generate. It can sort of generalize across. So you can ask something and it would sort of make a good response to that challenge. The same thing here, it's been trained on every sort of possible action scenario and can then generalize the actions to take across a lot of different applications. So I think it's a great way to see how generative AI is going to be used to simplify robot programming and make it very simple.
The next example is on reinforcement learning. reinforcement learning assembly, and this one features your UR5 EcoBot, where you executing single arm gear assembly using reinforcement learning. Explain this one.
This one I'm really excited about too. Assembly is in general a huge potential for automation across. If you look at general manufacturing, most analysis shows around 40% of all processes in general manufacturing is assembly processes in various ways. And doing assembly with very tight tolerances has notoriously been very difficult to automate with robots. Even using force control like our robot has, it makes some of the assembly simple, but as soon as it's something like gearboxes where you have multiple gears that needs to be meshing just perfectly right together, you may even have multiple gears meshing together. It's extremely difficult to program in a reliable way where you can just sort of keep producing and producing and producing. So this is a great sort of feature that iCare, which is one of our Swiss partners, have developed a toolbox for reinforcement learning based assembly. And what that means is that you would show the robot and sort of guide the robot slightly through an assembly of something like a gear to get it to mesh right. And it would then learn the end state of where everything needs to be fit in. And then over a bit of time, it's going to practice and rehearse and until it generates like what's called an AI policy of how to do this. The brilliant thing is that it's going to be an adaptive policy. So because I mean, gears will be in different positions at every new part. So we will not be the same motions going through all the time. It will be a bit of a tactic on how to wiggle these things in until they are just perfectly right. And what they've shown is doing something very complicated. The assembly application we have at our booth here, they're doing assembly on a gearbox from a Porsche Taycan. And they are just showing how it's even very fiddly for a human to do. And the robot can do it in a matter of 10 seconds. Slide the whole thing in. So this really is it's an example of a skill where you're mimicking, using reinforcement learning, which is really like a trial and error flow. Robot is trying a few times, and then within a couple of hours, it trains this policy to do assembly. And I think a lot of mechanical engineers can imagine how powerful it would be to have a robot that can assemble parts that have basically zero tolerance clearance, right? It needs to be perfectly right. And it needs this sort of very sensitive policy to accomplish that. So I see that having a great potential. And it's been built like a plugin for our Polyscope X software, which means that you can build all regular robot program. You can pick parts, you can place parts, you can do all the things that a robot would do. And then you have this smart skill that you train to do the actual insertion as a feature. So I see great potential in this growing toolbox of AI-powered smart skills across our cobot that would unlock a lot of these assembly applications out there. So it's a really exciting application.
The next one takes it even a step further. So bimanual assembly, we're really talking about complex manipulation tasks. What exactly is bimanual assembly?
So bimanual is when you're starting to use two arms. And I think when we think about a lot of applications that we see done manually today, of course, we always see people using both arms to do assembly. Traditionally, with robots, most things have been done with one arm. And it's often fairly straightforward to design application with one arm, but using two arms gives you the flexibility that humans have too. So our partner Archimino out of Seattle are doing what they call bimanual assembly. The technique is slightly similar to what ICA is doing on reinforcement learning, but in this way, it's using another AI technique that's called learning by demonstration. It's also one of the techniques we see a lot deployed with humanoids and so on, which is also often bimanual. But in this case, they have a sort of teaching handle. So what you put on gloves, where you have a tracking on the gloves, and you show the robot how to do a task. That could be putting together. They've been working with customers to do assembly on bicycles. They've been plugging in USB cables. They've been doing a lot of different applications that needs grasping parts and doing sort of fiddly assemblies, and maybe also handling tools, drilling a hole, screwing in a screw, and so on. And all of this can be trained by demonstrating for the robot how to do it. Then they learn this as a model, as an AI model. The brilliant thing is, as soon as it's learned into the model, then it would use cameras and forces to recognize if everything is proceeding as intended. So it will remain robust even with the small variations that every robot application would have, especially for assembly, but maybe you need the fiddly process of putting in a saddle pole on a saddle on a bicycle and so on. So this is really also taking assembly to the next step, where you will use AI to train by demonstration, learn the robot, build an AI model for how it should do it. And then also using what the superpower of AI is that it can adapt to these small changes according to your original demonstration. So I see that really also a great potential there. It's been attracting a lot of good attention from the audience at GTC as well, to see things that are all real world. These are things that you can buy, you can deploy them to factories today, but still leveraging the frontiers of AI, all the new generative AI that comes along. So I'm really excited about this one too.
Oh, for sure. Okay, the last one. This is with GroundLight, Workpiece Detection for streamlined picking. This is another good one, detecting a workpiece and generating a robot program for picking. Tell me about this.
Yes. So, and this specific demo, GroundLight is also one of our American partners. They are experts in anomaly detection and quality assurance. So they have also built a plugin that plugs directly into our new Polyscope X software, leveraging the AI accelerator to do the processing. And what they do is they have a workflow to support any application. The thing is, when you put robots into applications or sort of manufacturing processes that used to be manual, you often realize how many sort of small, subtle quality checks the manual operators often do. So that's one of the first steps that you often have to tackle as a manufacturer. It's like, how do you then deal with that situation? GroundLight has a perfect solution to that problem. You basically train the robot what goods looks like. So you will show them the right parts, you add that to an AI model, and if it sees anything that is different to these ideal models, it would prompt on the robot screen, say, hey, I saw something, this seems to be weird. Is this a failure? Is this a fault or not? And then you train the model. And the first time it will see it, you say, okay, this is a bad part. Please take that away. Then it generates a program for how to do that. You can also say, no, this is all right. And then it adds it to the good model. And within a couple of weeks, it will then build a very sort of sophisticated database of good parts, bad parts, and will automate all of that sorting. If you end up having a bad batch of parts coming along, let's say 1 year down the line, the robot will automatically generate, hey, something is wrong here. It will actually recognize that. It would prompt, and maybe you can then immediately start your QA process without sort of unawarely shipping multiple defect products to the market. It's a super intuitive workflow. It's very powerful. And what they even did, which I love, is they have integrated what is called a VLM. It's a sort of visual language model, which also allows you to prompt the robot system to look for specific things. So you can say, like, has all the screws been inserted into the part? And then it would check, or you could say, do you see 4 screws on this picture? And it would check that. And we see it like in the Universal Robots manufacturing line, as an example. We make sure we validate that the operators in all the manual steps we have put all the parts ready so that nothing gets forgotten. Some of those check steps you can fully automate with a system like GroundLight, because it would look, and you could just, with a text prompt, have that as a quality inspector, and then it would still have the same workflow. Hey, this looks bad. Is this truly bad? Yes, it is. There's a missing screw. We're demonstrating that at our GTC booth here today. We have a number of parts. Some of them just have very subtle scratches. Immediately gets recognized. We have a few screws missing. Immediately gets recognized. So I think these are all like AI-powered tools that really supercharges how easy it gets to build and deploy automation solutions. And what I really like, AI is now becoming sort of normalized, right? These are all things that will help you. Some of them will be sort of bigger features, like the bimanual, that's the whole system. But many of the small things we talked about, like the ICA assembly process, the GroundLight, is supporting technologies that just makes deployment of robots easier. similar to when you have AI tools on your iPhone. Well, it would recognize faces when you take pictures and whatnot. And it's not the big thing, but it really helps making deployment of robots easier, because it takes this superpower of AI that can generalize across things. It takes these very fine tolerances, this very deterministic behavior that robotics often have had a challenge of needing, and now it generalizes it, makes it much more flexible. So
yeah.
Hmm.
Oh, absolutely. And this is really fascinating, and I really appreciate how you've moved the needle forward. My next question, though, is, so these applications for the AI accelerator, these applications are germane to Universal Robots, right? What plans do you have to extend to other Teradyne brands?
So even like AI is important for all the Teradyne brands, right? Both for our Mir, the mobile robot platform, as well as for the Universal Robots brand. We Universal Robots launched this AI accelerator in November, and already today, as you can see, we have 4 products that are already ready and implemented with a bit more than 4 months, which is mind blowing to me. It just shows how much activity there is in the AI community. And they are so excited that we can offer them a path to market with these new technologies. We actually have more than 20 partners already developing on the AI accelerator, which is going to be great. Within a year, we're going to see so many different exciting applications. For the Mir brand, AI is also becoming a natural part of how they evolve the product. When last year, Mir just launched the Mir 1200 pallet jack, and that is a pallet jack capable of moving around in warehouses in manufacturing and transporting pallets around. It has sort of a full forklift and can lift them up and move them around. What's unique about the Mir 1200 pallet jack is that it already uses AI for the pallet detection. And you can say, well, why does it need AI? It does need AI because pallets in the real world have a huge variation. They can be damaged, they can be old, they can be dirty, they could be halfway wrapped into shrink wrap because that's a part of the pallet wrap. It may be black wrapping. It may have like a stapled on shipping label. In the real world, there's tons of variation. So classical methods of pallet detection is actually very fragile. It's quite often difficult especially in logistics scenarios, or if you have like goods coming in from multiple vendors that's been long-term underway. The Mir 1200 pallet jack is extremely sort of robust to all these things because they've been training an AI model for this pallet detection. So it's been trained on more than 100,000 real world scenarios that we've collected from a lot of our customers and early access partners. But they also then trained an AI model based on multiple millions of simulated pictures. So it really sort of covers a large variation of different things. This makes it very unique. It's super robust, and it can even, while it's sort of moving in and trying to dock with the pallet, if something goes wrong, if it's broken somewhere underneath the pallet so you can't proceed and so on, the AI algorithms would detect that immediately and sort of advise the pallet jack to stop and move back, try again, or even sort of announce it to the operators of the system. So we see this as really a natural element to a lot of the new products we build, that this sort of flexibility that AI provides as a superpower will spread across a lot of our products and the new things we do in the future.
That sounds very promising, and I think it's a great point to park our conversation for the moment, and I'll certainly be following up with you for some more application stories. So thank you, Anders Beck, for your time today and explaining exactly how manufacturers and developers can harness physical AI to create innovative robotics applications. And thanks to everyone for joining. I'll see you next time.